made by screwing them in place, each hole ready to let in water. Not what you want on a gallery filled with precious art. Bilbao's winters are renowned for being wet. On average, 1.2 metres of rain falls here a year. That's twice as much as falls on London. So how are the engineers going to make their building waterproof? The search for a solution takes us on a trip with Sir Walter Raleigh on his quest for El Dorado. The year is 1595. Sir Walter Raleigh and his fleet of Elizabethan explorers have crossed the Atlantic on the hunt for El Dorado, the mythical land of gold. His fleet is damaged and leaking. Limping round the Caribbean, he reaches Trinidad. And here he makes an important discovery: the largest natural lake of bitumen in the world, the pitch lake of La Brea. Now, this is probably the first time Sir Walter's seen bitumen, but he has the sense to use it to seal his ships and waterproof his fleet. Walter Raleigh used a crude, natural form of bitumen to seal his ships. For the Guggenheim, a slightly more refined version was needed. Unlike Sir Walter Raleigh, Dr. Ian Lancaster is a bitumen expert. So Ian, this is it then, the raw stuff in its basic form. You see, it looks like, to be honest, something that I'd spread on my toast. But it's not, is it?
Wouldn't do you much good.
But it has some amazing properties.
It's viscoelastic, incredibly adhesive, and it's 100% waterproof.
OK, now the waterproof I get, adhesive I get is sticky. Viscoelastic.
It changes its properties according to both temperature and the rate of strain.
Okay.
So if you look at sample here, this is a soft bitumen.
So why can't you then just paint a layer of this onto the top of the museum and job done?
It flows. You wouldn't want to do that because it would
just
flow.
fall off.
The soft bitumen would have been no use on the Guggenheim. It would have simply slipped off the curved structure.
But there are some other grades of bitumen which are quite hard.
Melt it like that and then paint that on, and then you've got a hard shell.
That's fine at high temperature. At low temperature, this gets incredibly brittle.
So,
have a go with that.
OK, so we'll just hit it.
Just hit it. Look at that.
That really is quite brittle, isn't it? That's clearly going to be no use once it's cool on the roof.
No.
This bitumen is similar to the pitch Sir Walter found at La Brea. OK for a ship, but no good for the Guggenheim. Once it sets, it would just crack and split as the tiles were screwed on. It wouldn't be very waterproof with cracks in it. They needed bitumen with something added to make it more flexible. Rubber.
This is a rubber modified one, and that gives it a concept called elastic recovery. Have a pull of that.
You say rubber modified, well, hang on, it feels so light. Wow!
It goes a long way.
Now, there's no way we could have done that with the other stuff.
No.
And then it's just returning to its original shape.
It'll go right back to its original shape. And when you think about it, on the roof of the Guggenheim, 264,000 screws go through this, puncturing it all the time.
Surely to me that just says, well, then water will get through the hole and it's no longer serving a purpose.
No, because as the screw goes in, the bitumen deforms and then it pulls back, so it wraps around the screw, making it completely watertight.
So even though they screw through this stuff, it actually sort of heals itself around it.
Yeah.
Because it returns to its original shape and that it's still waterproof.
Yeah, it self-heals.
So by adding rubber to the pitch Raleigh found in Trinidad, they've made the perfect raincoat for the Guggenheim. This is a titanium tile. Each one is folded over on the edges like this, so it hooks into the one above and below it. Beneath the tile is this, the steel layer. And between the steel and the titanium is this, the bitumen waterproof layer. And that's the secret, because when these brackets holding the tiles in place are screwed through, 264,000 of these screws, it's the bitumen layer that self-seals around it and stops them leaking. And it must work, because they've never found a leak. Well, that's what they told me, and I hope they're right, because I'm going to test it out myself in the middle of a lake. You may have noticed that I'm sitting in a rubber dinghy in the middle of a lake, and you may a bit like me, be wondering why. Well, I've devised a little test taking some inspiration from Sir Walter Raleigh and this nail.
The Guggenheim's engineers tested the waterproof membrane using a wind tunnel and some extreme rain. But I've got a different plan. I've coated the bottom of my dinghy with the same membrane used on the Guggenheim. And I really am hoping it does self-seal and form a protective layer because, well, it's just a few drops of rain against the Guggenheim. Here, it's me and this dinghy against 6 meters of water below. Still, what could possibly go wrong? The equipment is not complicated. Hammer, nail. Put nail through dinghy. Not something I'd advise anyone else to try on a lake, but I'm standing by for a huge gush of water to sink my boat, and nothing. I could sort of feel it as I forced the nail through. I could feel it seal around it, and there isn't, I would have expected just a dribble of water to come in around the edge where it's split, but I think probably the best thing to do with the experiment now is repeat it, because I have many nails.
Well, she's certainly not sinking. All I've got to do now is get back, maybe have a look underneath. And it's me power for that.
"33,000 square meters of the Guggenheim were covered in the same bitumen rubber compound that's under my dinghy. And so far, it's kept millions of pounds worth of art perfectly dry.
I'm out. I just want to see where the membrane's done its stuff. And there it is. You can see how it's sort of healed right around the nail, which is why it didn't leak a drop into my boat. So, Sir Walter Raleigh, a lake of bitumen and the amazing properties of rubber work together to help keep the Guggenheim's artworks protected from the elements.
But it's not just the weather that could prove disastrous for the Guggenheim. Being largely constructed of meltable steel, a fire would be catastrophic if it ever took hold. To solve this problem, the architects looked at the fieriest place on the surface of the Earth. A volcano. Fire always poses the biggest threat in public buildings, and obviously the public safety is paramount. But in an art gallery like this one, well, there are irreplaceable objects everywhere. The art. And you really should try and save that. The gallery has traditional sprinkler systems placed throughout, but they're only designed to cope with small, isolated fires. But what if a fire took hold? Obviously the people will have been evacuated and hopefully most of the artworks, but the heat of a raging fire can be devastating to a building, because once steel reaches over 600 degrees, it loses half its load carrying capacity. So the engineers needed something that would stop the Guggenheim collapsing. To find out what they came up with means going somewhere most people never get to see, inside the museum's walls.
Thank you. And now let me guess. Up the big ladder. And then I'm guessing it gets worse.
I just know it will.
Okay, up the big ladder. It is remarkable how many fascinating engineering connections are also very high up. Really big ladder. Nobody ever does any fascinating engineering near the ground. Always got to be high.
Fires in buildings can rage at over 1,000 degrees C and last for hours. Engineers needed a way of protecting the steel skeleton from the intense heat so the Guggenheim doesn't collapse, destroying millions of pounds worth of art. For the solution, the engineers turned to nature and used a naturally occurring fire-retardant substance that can withstand temperatures of over 1,000 degrees. And it's this mineral wool.
It's made from